Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to use a reaction with its rate law to find the amount of moles that are remaining after a certain amount of time, how many moles of a product is produced, and what the half-life of the reaction is. So let's get into this. So in this problem, the rate law for the reaction SO2Cl2 gas gives us SO2 gas plus Cl2 gas is the rate is equal to the constant K, which is 2.20 times 10 to the negative 5 per seconds, multiplied by the concentration of SO2Cl2 raised to the 1 power. So right away we can see from the rate law that the only thing involved in the rate law is the concentration of SO2Cl2, and it's to the power of 1, which makes this a first order rate law. Okay, so it's got first order kinetics. Let's move on and read the rest of the problem. If the reaction starts with 0.222 moles in a 750 milliliter flask at 320 degrees Celsius, how many moles of SO2Cl2 remain after 1 hour? How many moles of SO2 will have been produced? And what is the half-life of this reaction? Okay, so the first thing we need to write down is the integrated rate law and the half-life equation for a first order reaction. So for the first order reaction, remember it's going to be the natural log of substance A, whatever that is, equal to negative K times T for time plus the natural log of substance A initially. So the initial. So the substance A that we are using is going to be SO2Cl2. So also the half-life, by the way, the half-life equation for first order is going to be the natural log of 2 over the rate constant, which is equal to 0.693 over K. Okay, so the first thing we want to do is find, well, how much is left over after 1 hour. So we need to convert first hour. So 1 hour, we're going to convert that to seconds. We know that there are 60 minutes in an hour, so 1 hour on the bottom and 60 minutes on top. And then we know that 1 minute is equal to 60 seconds, so we'll put 1 minute on the bottom, 60 seconds on top. Minutes cancels out, hours cancels out, and we got seconds on top. So that's going to be 3,600 seconds. Okay, next thing we need to do is find the molarity or the concentration of our substance to start with. And they tell us that the reaction starts with 0.222 moles, and they're given the volume of the flask is 750 milliliters. Molarity or concentration is moles per liter. So we can change the volume, 750 milliliters, to liters. We know that there are 1,000 milliliters in a liter, so we'll put 1,000 milliliters on the bottom, 1 liter on top. Milliliters cancels out, and we have 0.750 liters. To find the concentration, we take the moles. The moles is 0.222 moles of the SO2Cl2. Divide that by the liters, 0.750 liters. Okay, so we've got that. Now we do the calculation. When we divide that, we get 0.296. 0.296 molar. So that's our initial concentration of SO2 SO2Cl2. And so now we can take this equation and plug everything in. So let me write it over here. So the natural log of A, this is A at some time t, that's what we're going to find. So the natural log of SO2Cl2 at some time t, the t is 1 hour. So this equals 1 hour. That's going to be equal to the negative k. K here is 2.20 times 10 to the negative 5 per seconds. So we'll plug that in. So 2.20 times 10 to the negative 5 per seconds times t. Time is 1 hour. We calculated that into seconds. That's 3,600 seconds. Okay, and then finally plus the natural log of the initial concentration, which is 0.296 molar. So 0.296 molar. Oops, let me fix that a little bit. So natural log of 0.296 molar. That's better. Hopefully you can read that. Okay, so now all we need to do is take the natural log of this, add it to this when we multiply. When we multiply this together and add this, when you do the natural log of this number, since this number is less than 1, you're going to get a negative for this. And then we have a negative for this. So when you add this together, you're going to get a negative overall. So this is going to be equal to negative 1.2965. Negative 1.2965. So that's going to be equal to the natural log of the concentration of SO2Cl2 at time t. Now, we have the natural log here. So the way you get rid of logs is that you write the log as an exponent to the base. So natural log has the base e. So we're going to go ahead and write this as the exponent to the base e. So we have e raised to the power of the natural log of the concentration of SO2Cl2 at time t. And then we're going to do the same thing on this side. We're going to raise this as a power of e. So this is going to be equal to e raised to the negative 1.2965. So what's going to happen is the e and the natural log as a power is going to cancel out, leaving us with the concentration of SO2Cl2 at time t. And then we just find this at e to the negative 1.2965. And when we do that, we get 0.27. Was it a 3? 346 molar. And then, of course, what are they asking for? We got to pay attention. So if this reaction starts with this many moles, they want to know how many moles of the SO2Cl2 remain after 1 hour. So we're looking at moles, but what did we calculate? We calculated molarity, right? This is concentration. So in molarity. So we're not done yet. So this is not the final answer. We have to convert moles. We have to convert the molarity to moles. So we have to go back to the volume, right? So then we take our 0.27346 molar. And again, that's moles over liters. So we write moles of SO2Cl2 over 1 liter. Our volume is 0.750 liters, so we're going to multiply to get rid of liters. So 0.750 liters over 1. So liters cancels out, and we get moles, which is going to be 0.205 moles of the SO2Cl2. SO2Cl2. So that's how you get that first answer. So the number of moles remaining after 1 hour is 0.205 moles of SO2Cl2. Now the next question is, how many moles of SO2 will have been produced? That's a stoichiometry question. So they gave us the balanced equation here. So we're going to use that balanced equation to convert the amount of SO2 that was produced. However, we need to know how much reacted. So we're going to go ahead and erase this since we don't need this anymore. So for this, we have 0.205 moles of the SO2Cl2 remaining. So we need to find out, well, how much reacted. So we started off with 0.222 moles of SO2Cl2. We have 0.205 moles remaining. So we're going to subtract that 0.205 moles remaining of the SO2Cl2. If we subtract that, then we have 0.017 moles of SO2Cl2 reacted. This is what we lost. So this is what has been converted into SO2, the product, right? So we have the product there. So we're going to use our stoichiometry. Notice that we have a 1 coefficient here and a 1 coefficient there. So the mole ratio is 1 to 1. So we're going to use that as a conversion factor. So we're going to start with 0.017 moles of SO2Cl2 over 1. We're going to use the mole ratio as a conversion factor. It's 1 to 1, so 1 mole of SO2Cl2 on the bottom and 1 mole of SO2 on the top. So moles of SO2 cancel out, and that leaves us with the same number of moles, 0.017 moles of SO2 has been produced. Now, you probably could have eyeballed it and figured out, hey, it's 1 to 1, so it's the same, and you could have foregone the calculation. But I like to use my conversion factors. I like to show how you can get the answer from conversion factors using the mole ratio stoichiometry. So now we have that answer there. Now the final question is, what is the half-life of the reaction? So we got to go to our half-life here. So the half-life equation, the half-life is equal to 0.693 divided by K. K, the rate constant, is 2.20 times 10 to the negative 5 per second. So we're going to just use that equation. So the half-life is equal to 0.693 divided by 2.20 times 10 to the negative 5 per second. And remember, we have our unit on the bottom. It's -1. If we bring it to the top, it's going to change sign. So that means we're going to go from per seconds to seconds. So our final answer is going to be in seconds. When we calculate this, we get 31,500 seconds. That's a very large number of seconds. Let's try to get that to a more manageable unit like hours. So if we take the 31,500 seconds, we can use our conversion factors to convert that to hours. So 60 seconds on the bottom, 1 minute on top. And then we can use the conversion factor of minutes to hours. So 60 minutes on the bottom, 1 hour on top. So minutes cancels out, seconds cancels out. Now if we do our calculation, we get 8.75 hours. So that is the half-life of this reaction. That's it for this video. I hope you enjoyed the video. I hope this made a lot of sense. I hope this was helpful and fun and entertaining. If so, then please like the video, share the video, hit that like button somewhere over there, or you can find it. I believe in you. Also, do me a favor, subscribe to the channel. If you haven't, why not? Do it now. It's really easy. Just click the button. Also, hit that notification bell when you do. Click all so you can be notified by all the videos that I put out. And finally, put a comment down below. I would love to hear from you if you have a question or a problem you need help with or a topic you would like me to cover. Put it down below. Let me do it for you. Thanks for joining me. Have a great day.